All right. Hello, everyone. Today we're going to be presenting Sisyphus in the CVE feed and talking about how we worked on automating our vulnerability management program. Quick legal disclaimer, we have pretty strict rules of what we're allowed to share and what we can't. So while we've tried to be as clear as possible, there'll be some places where we have to be a bit vague on the data. All right, so quick introduction time. My name's Keziah. I'm a senior software engineer at Airbnb on the information security team. I've been at Airbnb for almost 6 years now. I describe myself as more of a builder than a breaker. So thank you to all the hackers out there who keep my job interesting. And fun fact about me is that I was actually born in Osaka, but my parents moved away when I was 2, so this is the first time I've been back since then. So it's been really exciting to be here.
Hi, I'm Kadia Mashal. I'm an engineering manager at Airbnb. I've been with Airbnb for over 4 years, started as an engineer, and now I'm an engineering manager. But one fun fact about me, my first time in Tokyo, big thank you to the Code Blue staff who allowed me to change my picture very last minute. So I went to Team Lab. If you have not been to Team Lab, please go. It's such an amazing experience here at Tokyo. So that's where I took the picture and they allowed me to update it. So thanks again. And yeah, let's keep it going.
All right, so full disclaimer, if you're here to learn about Greek mythology, that is not the topic of this talk.
Sorry.
But I'll give a quick summary of the myth of Sisyphus if you aren't familiar with it. So it's from Greek mythology. It's about a mortal named Sisyphus who angered the gods by his general trickery and trying to cheat death. So the gods do manage to punish him, and what they force him to do is essentially roll a boulder up the hill for eternity. And once he manages to push the boulder all the way up the hill, it immediately rolls back down, and he has to start the task over again. Just like a never-ending problem he has to repeat for eternity. So if you work in information security, that feeling may resonate a little bit with you. We may not be pushing a large rock up the hill for eternity, but it can definitely feel like we're fighting a losing battle against never-ending stream of CVEs.
So before we talk about how we automated vulnerability management, we'll talk about the fundamentals first. So we all know there is no such thing as software that is clean and has no vulnerabilities. That's the dream, unless you remove your code base, but that's obviously not ideal. We want to talk about how you should design and implement a process that can efficiently meet the vulnerability lifecycle requirements. So if you're not familiar with the vulnerability lifecycle, first of all, it's very common for a company. You find a vulnerability, you detect it. This can happen through pen testing, vulnerability scans, bug bounty, you name it. Exactly. And the next step is where you assess the vulnerability. How many of you have seen vulnerability reports that weren't applicable? Can be very noisy. So the third step of a vulnerability lifecycle is when you report on known attack surface and share metrics. And the fourth step here, which we consider very critical, is remediating and preventing the vulnerability in your environment. So what are our objectives when we started thinking about automation in our organization at Airbnb? First, we are a cloud-based company. We use AWS, which means in the cloud you can expand and change your environment very quickly. So our objective here was to support the changing environment as quickly as possible. And as you all know, as you expand, that also means your attack surface increases. So you wanted to build something that can keep up with those changes. We also wanted to make sure that we just don't find vulnerabilities, but we also quickly remediate them, but also verify that the vulnerability has actually been fixed. We also wanted to make sure that we build something that can help us address and prioritize vulnerabilities. All of you are familiar. There are hundreds of vulnerabilities that get released every day. How do you keep up with that? And how do you prioritize and focus on the actual risk in your environment? Another objective of ours was understanding the root cause of vulnerability. How did the vulnerability get integrated or implemented in the first place? So understanding the root cause of a vulnerability was incredibly important to us. We also wanted to build something that is vendor agnostic. Regardless of which tool you use, your infrastructure, your vulnerability management program should be robust, regardless of any vendor limitations that you have in your environment. As you can tell, I was not hired as a graphic designer for Airbnb, but I wanted to highlight quickly that what the traditional vulnerability management program is. So most of the companies have a bunch of vulnerability sources, like for instance, threat intel, vuln scanners, bug bounty, security tweets. And most of the time, you have one security engineer, some security resource that has to go through this entire noise and then forwards the vulnerabilities to the remediation owner. That's obviously not ideal because you're a bottleneck and it's taken away from critical vulnerability remediation time if this process is operational and manual. So what challenges did we face when we started building the automation? Risk assessment. If you're familiar with vulnerability advisories, each vulnerability has a CVSS score or a severity associated with it. And not all of them necessarily are always applicable to your environment. So how do you make sure that it's contextualized? So most of the security advisories are very vague, inflated severity ratings, or the exploitation is incredibly hard, and or it just misses context that is relevant for your environment. So which brings us to the next point.
So here's a good way I like to think about dealing with inaccurate severity scores from your many scanners and vulnerability sources. So this is the Winchester Mystery House at San Jose, California. It's famous for having been built by an eccentric woman who put a lot of weird features into the house. For example, this door on the second floor that just opens out to nowhere. So let's see, here we are at work, and then we get a scanner telling us there's a critical vulnerability just dropped. Go, fix it immediately. It's an open door. But then we take a step back and look at it in the context of our infrastructure. Yes, it is an open door, but it's on the second floor. There's not exactly an easy way for someone to climb up there. Someone would probably have to bring a ladder, and with our existing mitigations, we would probably notice someone dragging a ladder across our property before they even make it there. So this critical vulnerability, when looked at with more internal context, is probably more like a medium severity. Doesn't mean it's not a risk, but it's not as high a risk as the scanner tells us. And again, this changes so much for company to company. In another company, that door could be on the first floor. So that would be a true critical in that case. But that means you keep spending time over and over again filtering through these large feeds, trying to decide which ones are true criticals or which ones are actually lower risk in your environment. And if this is happening constantly with never-ending CVE feeds, it gets very overwhelming.
Another challenge that we faced is inflexible vendor features. All of you probably worked with vendors before. There are many great vendors out there, but most of them require some sort of customization. For instance, they tell you we have reporting pipelines that you can use, but if you look into it, they don't allow you to change the severity rating, which again introduces operational work. So, which brings us to the next point. Every time you introduce a new vendor in your environment, it means you have to create operational work as well to customize it to your environment. And one thing that I also want to highlight is every time you implement a new vendor in your environment, you increase your attack surface. So it's not just the operational work, it's also from a security perspective, something that you should keep in mind, and something that we had a challenge with. Also accountability. How many of you or probably know that security is maybe not always the highest priority in the business? So accountability was definitely a challenge for us. And how do you make sure that people are engaged and responsible for the vulnerabilities that they introduce?
All right, so with those challenges and objectives in mind, our team tries to stick to some general guiding principles. These aren't set in stone. There's always exceptions, and we definitely do not accomplish them immediately, but it's kind of a North Star we want to always be heading in. All right, So, as mentioned earlier, default severity scores can be inaccurate without context, creating what I'll call here a false positive. To be clear, I'm not saying there isn't risk associated or it's a fake vulnerability, but rather it's a false positive in that it's not the severity rating provided to us. It's still important, but maybe it's not the thing that needs to be fixed first. So just relying on default scores like CVSS scores is not actually sufficient to automate the risk and still requires human intervention to parse through. Now, it can be really tempting to want to catch every single potential vulnerability, but might as well just look through everything provided. And the intention is good. It's better safe than sorry. I'll call this the maximizing true positive solution. But this is a misconception. Humans are not going to catch 100% of vulnerabilities. There's alert fatigue. People misread or misunderstand things. A major security principle I'm sure we're all familiar with, humans are the weak link in a process. And we can't also forget that undisclosed vulnerabilities exist. There will be vulnerabilities in our software that a scanner will not tell us about. And so relying on trying to have a manual person go through everything is not going to catch everything, and at the same time creates all these challenges we had mentioned in the beginning. And let's be real, a lot of the time, a lot of the most severe vulnerabilities are dropped by an anonymous Twitter account. So our biggest goal here was to create a system that does not rely on human intervention to triage risk. We wanted to focus on cutting the human element out as much as possible by automating the risk assessment process to ruthlessly minimize these false positives as much as possible rather than maximize the true positives. And so this can make people feel really nervous because, what if we miss something? However, as I keep hammering down, there is nothing that is going to catch every vulnerability. The boulder is not going to stay on top of the hill. And so since that's impossible, it's much better for us to be prioritizing things like remediation speed so that we get vulnerabilities out of our infrastructure faster, because the longer you spend on manual triage, the longer a vulnerability is in your system. So, this brings us to our next point. Accepting this principle means that we're accepting an imperfect detection strategy. That means things will slip through the cracks. We also can't ignore those. What should we do about that problem?
So what we want to highlight is here paired detection with preventative measures. It is definitely important to balance the risk by making sure that you block vulnerabilities from being introduced in the first place. Do not rely on detection. If you wait for a vulnerability report in order to act and harden your environment, that's not going to be scalable for you. Also, you should be thinking long-term versus tactical. And you can achieve that by being proactive versus reactive. For instance, introduce a standard deployment pipeline in your environment. Make sure that people follow a standard deployment process. CI checks. Make sure that when you deploy code, especially packages, that they're flagged if they're insecure so that you stop the vulnerability from being introduced in the first place. Also, image auto-rotation. Don't wait for vulnerability reports, especially. Again, as Keziah mentioned, not every vulnerability has been disclosed. There are many vulnerabilities out there that we don't hear about until 3-4 months later. So again, make sure that you're proactive and constantly rotate images. And if all of these steps are challenging for your environment, there is always the traditional approach where you can at least have a patch cadence to address the vulnerabilities that are in your environment.
We also can't neglect building relationships. All the automation in the world won't necessarily be helpful if you're antagonizing other engineering teams in your business. For example, it's really important to balance security and developer productivity. Trade-offs are important. We don't want to be sacrificing the effectiveness of our engineering teams for a low-priority security request that may not need to be fixed immediately. Within reason, we're not saying compromise security, but we're saying that it's really important to prioritize what you fix and may also think of creative solutions that can work for everyone. For example, it can be really helpful to work with other teams to pair security benefits with their engineering goals. So we benefit by integrating security while another engineering team gets to deploy or work on something that's within their scope. So we've made the mistake in the past of being too top-down, but it's never been as effective as when we've treated engineering teams as our partners, sought their input, and tried to make it mutually beneficial.
So again, we mentioned that accountability was a challenge. So how can you as an organization deal with this problem? The way we deal with accountability is set SLA, service level agreements, based on risk. So for instance, set expectations when a remediation owner should be address a vulnerability. And also allow extensions. If you have mitigations in your environment, there is no need to focus on the wrong risk. Focus on the critical risk and allow for lower risk SLA extensions to happen. Also, especially for organizations, make sure that security metrics are part of business metrics. How many times do you hear in organizations talk about downtime? But security metrics should be also part of your business metrics, because security metrics also have a picture about your business and also give you a picture about your posture. Also, invest in asset ownership. Again, the quicker you find a remediation owner, the quicker the remediation will happen. Most of the time, we don't think of asset ownership as a security problem, but if you do not know who's supposed to fix your vulnerability, that's a lost battle. You know that the vulnerability is in your environment, and you are not taking quick enough steps to actually remediate it.
All right, so with that in mind, let's go into the system we built to manage our vulnerabilities. All right, step 1, aggregate and process vulnerabilities. So depending on your setup, you may have any number of scanners. They probably have different formats, different levels of information provided. They're also siloed. They don't know about each other, so you have to be looking at different locations for different vulnerability reports. And as mentioned earlier, while some do have some limited automation features, it doesn't usually allow for much customization. So instead of just using a scanner out of the box, what we do is import the data, standardize it, centralize it in one place. And so this lets us do things like deduplicate repeated reports from different scanners. We also track every unique vulnerability with a UUID. And this is a key part of how we track a vulnerability through its life cycle. Our general thought is that a UUID should represent an asset and a vulnerability. And it's even better if you can connect the UUID to the associated fix. So, for example, let's say you have a scanner that says in cluster A, there are 100 CVEs stemming from a vulnerable software package. There's no need to track every single individual CVE. What we need to track is the package version on that asset. So once we see that that asset no longer has that vulnerable package, then we know that any CVE associated with that package is fixed.
So I mentioned earlier, contextualizing the risk was a challenge for us. So the way we fix that problem is we build a risk service. This risk service collects metadata about every asset in our environment and the associated metadata with it. So for instance, think of it this way. If we have an asset in our environment, we collect information about is it accessible over the network or accessible internally only. What type of data does the asset actually handle? Is it PII or is it data that we may not care as much about as sensitive information? We also try to understand what type of access control does the affected asset have. So if a vulnerability is affected, if an asset is affected by a vulnerability, how far can a hacker go? So we try to collect information about the access controls and the IAM permissions of this asset. We also collect information about every vulnerability that is associated with this asset to have a better understanding of the risk in case of a disaster. So again, think of it this way. So we have the asset risk information that I just told you about from the risk service, but we also collect vulnerability data from multiple sources. So as I mentioned, vulnerability scanners tend to have one standard CVE rating, a CVSS score, but we also collect information from Red Hat, Amazon, a bunch of open source solutions out there offer an API that give you actually a lot of vulnerability data that you can break down into your and store in your metadata. Think of it of this way. If you have CVSS, you can break it down and understanding the exploitation. Does it require user interaction? Is it an RCE versus local escalation? So again, break down the vulnerability metadata as much as possible and store it internally. The more sources you have, you better risk signal you will have when you automate this process. A great example here to share with you. Imagine it this way. You have a vulnerability in a sandbox account, in an isolated developer account, and you have a vulnerability in your production environment. You should not prioritize the sandbox account vulnerability the same way you prioritize your vulnerability in the production environment. You should adjust the risk based on the asset that you know the metadata has shared the info about.
All right, next, reporting and remediation. Now, all that information can be passed into our reporting service. And our reporting service doesn't need to care about any details of the vulnerability. It doesn't need to know what scanner it came from. It doesn't need to know if it's a misconfiguration problem or a CVE. This is where the UUID comes into play again. The reporting service uses it as a way to track the status of a vulnerability at any point in time. And in a few slides, I'll go into the technical details of this reporting service. And lastly, verification. Our motto is trust but verify. People will try to fix something, but mistakes always happen. So we want to assume that that can be the case and rely on programmatic verification so that we have confidence that the vulnerability is no longer present in our infrastructure. So here we can use the UUID again. If we're tracking a vulnerability via the asset and associated remediation, then we can know if something's fixed by checking for the presence in our infrastructure. So, as mentioned earlier, if the vulnerable package version isn't in that asset anymore, then we can feel confident that the CVE is gone. Now, what's important is to take this one step at a time. This is a really long process. Every company has unique problems and legacy infrastructure that doesn't fall neatly into a single solution. So contextualized risk might be really hard with your legacy code. Maybe just start by being able to centralize all your vulnerability in one place for tracking and metrics. Or let's say you don't have any metadata in order to find things like ownership or increase the accuracy of your risk assessment. Just start collecting it now, even if you can't use it for a while. And partial automation is still better than no automation. At least you're reducing the time on manual operational work, even if some does happen. And so that means your security engineers can still spend less time filtering through all this noise and actually get to prioritize proactive remediation work and use their time more wisely.
Or more hacking.
All right, so how do we scale to more easily integrate different kinds of vulnerabilities with this process? As I quickly mentioned earlier, what ties this together is our reporting service. So, quick background for our architecture. We're a use cloud infrastructure, and we are a service-oriented architecture. So one of the biggest asset use cases for us are microservices.
Quickly also about the tech stack, we do not use any vendor UIs. We don't use out-of-the-box deployments. We leverage vendor APIs for various reasons. Obviously, you can standardize the format, etc. But we also use Apache Airflow, which Airbnb open sourced. As I mentioned earlier, there are a bunch of different vulnerability sources that constantly stream vulnerabilities. So Apache Airflow is a great data management platform that lets you handle large data sets. Another thing that we also use is Hive Presto, also open source, where we store large data sets, again, to standardize and create the formatting for the reporting service that we're interested in, that we use. We also use Spinnaker, which is a deployment tool, and again, Keziah will go into more detail about the Spinnaker use case here in the next slides. We also use ticketing APIs. We do not use reporting ticketing UIs. We try to leverage the API for bulk tickets creation, etc. But I do want to highlight ticketing is usually the last resort, so you should definitely focus on remediation and prevention.
Yeah, our goal is to first try to solve it with proactive measures before we go to just reactive ticketing. All right, so how does our reporting service work? So we have a client that writes code to ingest vulnerabilities, standardize them, and calculate risk. Then the client plugs it into a reporting service. And after that, the reporting service can handle the rest. So there are a lot of benefits that come with this system. It unifies all the shared implementation. Clients don't have to worry about reinventing the wheel and having to do their own ticket creation or having to do their own asset ownership finding. Handles things like deduplication. Client doesn't have to worry about accidentally reporting something twice and having something like multiple tickets created. The reporting service has all that tracked and knows when something is new and when something isn't. It also allows us to have centralized metrics tracking via the UUID. We can track remediation by connecting to the ticketing API. And having everything centralized allows us to potentially see patterns and maybe identify weaknesses in our infrastructure that we should devote more resources towards hardening. And so this makes it really easy to scale with additional vulnerabilities you want to track. The functionality is modular. Anyone can write the code ingesting the data and process it, and then pass it into the reporting service. And this made the process significantly more efficient. We don't have to be the blocker for tracking all vulnerabilities. We don't have to own every single scanner for our company. We just need to maintain the service for other people to use. And that also means we don't have to make a different flow per scanner type. Whether or not it's an insecure configuration or if it's a CVE, the same flow is always used. And after we deployed this, multiple security teams were able to start using it immediately. And if a new vulnerability drops that doesn't fall within our standard scanning flows, we can start tracking it right away.
So we spoke a little bit about the automation. What results did we experience? This is not a Bitcoin slide, but I do. So we were not allowed to share the actual metrics from our legal team. They were very tough on that. But we did want to highlight with you how the risk significantly went down when we started contextualizing the risk. So again, instead of seeing hundreds of criticals in your environment, contextualizing the risk actually allowed us to focus what the actual risk or the highest risk in our environment is, and remove all the noise. And again, removing the noise means also less operational time, and security engineers can focus on breaking and building secure infrastructure versus going through a bunch of vulnerability scan reports and just waste time on that.
Another use case scenario is how this helped us jump on Log4j quickly. All right, so timeline. Log4j dropped right before the holidays, as is tradition. So when that happened, we quickly wrote some code to track all the Java services that would need to be patched. We then integrated it with our reporting platform. So that pulled information from Hive and then created tickets for all service owners, along with instructions on how to apply the patch. Service owners then receive the tickets and work to apply the patch to their assets. And simultaneously, we wrote code trying to use our internal deployment data in order to verify if a patch was actually applied to a service. And so if there was a service owner that made a mistake or missed something, we could let them know what happened, and so they can go back and correctly fix it. And I wanted to provide this as an example of how building a vulnerability management platform can allow you to quickly respond to new kinds of vulnerabilities and to be creative in your solutions. So if something falls out of your scanning flow, you don't have to create a whole new system to track it. It uses the exact same tracking system as any of your scanners in your environment does. And you don't have to rely on just the default data provided by a single scanner. You can use as many sources as you can get to help you. In our case, it was significantly faster to use the internal deployment metadata in order to detect and verify that the patch had actually been correctly applied. And if we had used just a default pipeline that wouldn't let you customize inputs, that would have been a lot more difficult. And so leveraging existing tooling and metadata like this means that you don't always have to be deploying a brand new performance-heavy scanner solution. You can use the information you already have to do so.
So yeah, one of the goals that we really want to convey in this presentation is be vendor agnostic. Design your infrastructure for your environment, not for a vendor. Make sure that you leverage vendor APIs so that you create standard formatting for the vulnerability databases instead of having vulnerabilities staggered all over the place in multiple solutions. Also, make sure that you explore non-traditional or open source security solutions. For instance, Keziah mentioned that we use Spinnaker to verify that a vulnerability has been fixed. So instead of running a performance-heavy vulnerability scanner, no, we had deployment metadata already in our environment to verify the fix. Or, for instance, OS Query. OS Query is not a vulnerability scanner, but we leverage OS Query metadata to understand what type of packages or what type of information and metadata do we have about an asset versus, again, rolling out more and more agents, which means, again, you increase your attack surface the more agents you deploy. So, again, leveraging maybe existing agents in your environment will save you money, but also reduce the attack surface in your environment. Also, make sure that you don't rely on just vulnerability scoring data from one source. Like it's very common in the US to rely on NVD and the National Vulnerability Database. But one thing that we really try to do is leverage vulnerability data from multiple sources. It will give you a better understanding about the risk of the vulnerability. And also, again, there are a bunch of open source solutions that you can leverage. There are not, again, they're open source, and it's great when, especially when the business is not invested in spending more on the security solutions. Again, so here are a couple of open source solutions that are out there that are reliable. Some of them are open source by Airbnb, Google, NCC, Meta, OS Query. So again, all of these solutions definitely helped us automate our vulnerability management program. So let's talk about the takeaways. Yeah, invest in robust metadata. Do not rely on single reports from each vendor solution or scanning solution. Collect every metadata that you have in your environment. It will help you address a vulnerability more quickly, and it definitely helped us. Also, it will also allow you to contextualize the risk. So for instance, if you have metadata, you can always increase and adjust the risk assessment in your environment. And again, as you remember the Bitcoin slide, so you will definitely see a slide, you will definitely see a down in the criticality of some of the false positives. Also, one thing that we want you to focus on is, again, it's great to report on vulnerabilities, but make sure that you invest in the root cause analysis. If you have a standard vulnerability, if you standardized vulnerability information in your environment, you will see patterns. That means you will understand the root cause of the vulnerabilities, and that focus on prevention in the first place. Use the security engineers for fun projects instead of letting them just go through vulnerability reports or noise from bug bounty programs, etc. Again, I'm not saying that vulnerability scanners are bad or bug bounties are bad, but there is a lot of noise. But focusing on hardening your environment is definitely something that will help you long term. Also, one thing that I also want you to take away, move away from the traditional vulnerability management program, which is very manual, and you have one bottleneck, the security engineer or the security person review all of the vulnerability sources. It will take away from critical remediation time. Automate as much as you can so that you can scale and detect and remediate vulnerabilities as quickly as possible.
All right, first we'd like to thank the Code Blue staff for all their hard work. We've had a great time here and everything has gone so smoothly. We'd also like to thank some of our coworkers, Deanna, Derek, Jawei, Tina, Chris, and Mark, for supporting us through this project and also this talk. And Q&A time. And in addition, if you're also interested, we do have a blog post on this topic on the Airbnb engineering blog. And we've also added our contact information here. And we'll also be at the networking event to chat with anyone who is interested in this.
Thank you. Arigato.
Thank you for the presentation. We still have a few minutes for questions if somebody wants to ask from the audience.
Sure. Yeah.
So one of my questions is regarding adding to your data risk model. Do you have like an onboarding process for the projects so that you have the code owners, you have the dependencies that they use so that you can hook that all in? Like, is there a process for new repositories and systems to come into the system?
Yeah, we definitely have, we do have that. There is a standard way, but of course there are outliners sometimes that you have to still deal with. So it's a learning process. So the more metadata we collect, we sometimes, like you can apply machine learning where you can, for instance, guess who the owner is, who committed the code last. So again, any API that we have available in our environment, we just fetch the data and try to learn as much as possible and then apply it to the standard process.
But yes, definitely over time, we started having a lot stricter rules of when you're starting to add assets, you have to start tracking that information rather than having just ad hoc assets that nobody knows who owns it.
Yeah.
And I had one other question
Sure.
regarding the data risk stuff again. Do you have to work with your compliance teams to categorize like the risk for data and all that stuff as well?
Yes. So, for instance, in the risk service slide that I had, where we spoke about PII, for instance, if the asset is handling PII, that obviously means it's critical. Even if the scanner or the pen tester, etc., says it's maybe a medium-low vulnerability, we make sure that we still prioritize it because we obviously at Airbnb care about your data. I hope you all use our product, but but on a serious note, we really want to make sure that it also works with compliance and any kind of regulations in our risk assessment.
Great, thank you.
Sure.
Okay, are there any more questions?
Yes, one over here.
So thank you for a great presentation. You talked about the importance of gathering data from lots of sources.
Right.
Some metadata is delightfully machine readable. Some really isn't, and so adding more data could make it trick. Could you talk about what's the data that helps you easily automate, and what's some of the data that you found really hard to automate that we may want to work on improving?
Security advisories. All of you probably know there is no standard way of security advisories. I know Google and a bunch of other products have tried to do that, but if you look at package parsers, etc., it was definitely difficult. So we had to spend a lot of time creating it into, for instance, a JSON format, etc. But JSON format definitely helped us with standardizing. Yeah.
But yeah, that's definitely a challenge we've faced which is why we spend so much time searching for different sources. Because sometimes we'll find a source that seems really great, and then we realize we have no way to automate it. So it's definitely kind of I would say, an industry challenge that I really hope that we start prioritizing machine-readable reports.
Can I put in a plug for the Common Security Advisory Framework, or CSAF, which is a new OASIS standard?
Fantastic. Noted. Thanks for the comment. Yeah.
Yeah, we're always, and I think it's definitely been over time, people are really starting to prioritize it. There are definitely things that do not fall under that, but it's been really great over the last few years seeing an increase of people prioritizing machine-readable formats.
Yeah. Hello.
Hello. So are you dropping the CVSS score, or are you using the CVSS score? Are you purely contextualizing it based upon where what services impact?
All the above.
All the above.
All of the
All
above.
the above.
No, we try to not only look at one score.
Yeah.
So we compare, different advisories can actually have different scores. So we like to look at different kind of sources and see how they differ.
There's certain advisories, for instance, they don't use CVSS at all and just tell you the criticality based on the vendor. So we take that and apply it into the database that we use for the risk calculation. So we try not to rely on CVSS only. So we try to break and use more sources as much as possible. And I think you had another question as well, right?
Yeah. Do you have a human in the loop on some, all, any, none?
Oh, yeah, of course. So instead of looking at 300 vulnerabilities a day, we look, for instance, something that we consider critical, or for instance, pen tester. Like, for instance, if you have a human who finds a vulnerability or a bug bounty, we tend to make sure that we prioritize that because, again, these are usually more qualified findings if you're a good pen tester.
Yeah, this I'd say is a very hard problem. I don't know if it'll ever be possible to 100% automate it.
But reduce the noise.
But the point is to reduce the noise so people are not spending as much time on pure noise that we could automate away. Things like, 0 days dropped on Twitter. All of us will have to go look at it and actually evaluate it.
Yeah, that's another thing that we really, security advisories, when vulnerabilities drop, especially when they're vague, you definitely have to sometimes sit down and look at the code and the function that is being used, etc. So you can't fully move away, like Keziah said.